right? I don't think there's any like magic thing that's going to happen, although AI may make it faster, right? So that's the big thing that's happening right now that's new is kind of the AI thing, right? And what we've been able to do, and this has happened in inspection technology right now, so vision inspection. So we historically take a camera, like let's say there's I don't know, it doesn't matter what it is, some part, something that you want to know if it's correct. Like we already talked about how we could locate a part using vision, but that's really like not the same thing at all. Like I don't need AI to locate a part. Maybe I need an AI to identify a part, or I need AI to identify defects in a part. So you tell me if it's good or bad. So quality is where the major application for AI is, even in part, not detection, identification. It's less important because generally you know what a part looks like, and so you can train a vision system without a complex AI, right? It's not that difficult. So what AI would be good for in part identification would be a machine that you don't train. You would simply just start running a new part, and potentially in the future you could use AI to figure out what to do with that part. That's kind of a long way off, right? But defect finding, quality is actually what we've been using AI for the last, it started out maybe 5 or 10 years ago with these like deep learning models, right? So they started so historically before that, what we would have to do is basically identify all defects, all possible defects, right? Any failure mode of a part. And then we'd have to write code to, say this is a defect and this isn't a defect. And what I mean by that is in a vision model, what you would do is it's still like abstracted from writing code, right? You'd basically, you'd identify in an image, right? Because the image it should be a fixed image. You should fixture the part so it's a fixed image. You always see the part in the same way every time. So you could like simply identify, like the person could identify the defect and then say what constitutes a defect. And what I mean by that is like, so this black area right here is a problem, right? If it's black, it's a problem. So I can say if the black is more than 20 pixels big, it's a fail, right? So I would have to identify all failure modes, and it could be generic where like any black on this part that's bigger than 20 pixels is a fail. So that's kind of a general one, but it could also be like only here, this black is here would be a problem, and white over here is a problem. So I have to identify all the different failure modes, which could be could be nearly impossible, right? So like a part, you don't even know what all the failure modes of a part are until they happen sometimes, right? So in the old days, developing this technology, you'd run the parts, you'd preemptively determine what all the failure modes you could come up with were, and then when the parts were running in real production, you would still get bad parts through the system occasionally because you hadn't identified that as a failure mode yet, right? Mm-hmm. So then the deep learning stuff started 5 or 10 years ago, and you could train the system to start recognizing new failure modes based on previous failure modes. And this has now evolved into AI, right? So it's the precursors of AI. It's the same stuff, right? It's right. Basically saying, okay, the system is now smart enough that you can just say, good part, bad part. You can like take pictures of 1,000 parts, say good part, bad part, good part, bad part, whatever, to all of them. And then the system can then extrapolate what the failure modes are, right? Yeah. And that's kind of where we are now, which is a huge difference from the past, right? Like, yes, it wasn't really like, I mean, it's programming to some level, but it's pretty easy programming because it's sort of a fourth generation language. It's like almost not a language that you use, more visual to do this kind of programming. But well, that I say that, but then that's not all the way true. There are to do the high-end applications, you always had to actually code. But now with AI, a much less trained individual can develop this, right? So you can push a lot of this onto the customer as a sorry, as an integrator. That's super beneficial for us, because if they want to add a new part, they can just add a new part, right? And the system's smart enough to figure out what to do with that, right? So that, or they can hire us and we can do it too, but it's much easier for us too. But that kind of thing is now happening, right? So we now have, you know, that level of AI, or I don't know, machine intelligence, right? That it can figure out from some images, it can figure out what's good and bad. Like if you have to tell it, but it can figure out, like it can extrapolate the future. I think that there's a pretty big jump that happened there, right? That could also happen in things like part, you know, pick and place operations, robots, right? So the robot could now solve the problem of how to do this pick and place operation with very little input from the person, right? Like it definitely is much harder, and this hasn't happened yet, but I think that this is possible. So I think that maybe in the future, like path planning will be something that AI takes. And when I say this stuff, this is manufacturing environment, right? Like, so if you go into, they're trying to build like commercial consumer kind of robot stuff. I don't have any idea. I'm I'm skeptical of the commercial stuff currently.